So the course that is meant for the mid-sem examination, that is the congestion control. Okay, so this will finish our course once the congestion control is over. As far as the flow control is concerned, if I look into this diagram, this is the sender, this is the receiver, let's say. Okay, so this is my sender, this is my receiver, and this is the network. This is the network through which my sender is connected to the receiver. So whenever we talk about flow control, it is about the sender and receiver. That means controlling the speed of the sender based on the capability of the receiver is flow control. Okay, that means what flow control talks about? Flow control talks about, so that means controlling the sender. Controlling the sender based on the receiver. Based on receiver capability. We do not know anything about the network as far as flow control is concerned, but that is not sufficient enough. I have already explained. So that is not sufficient enough to achieve reliability. So to achieve reliability, also we have to take into consideration what is the network capability. So that's why congestion control deals with the capability of the network. Based on the capability of the network, deciding what should be the sender capability. So that's why congestion control is saying controlling the sender based on network capability. Okay, that's the difference. Okay, so flow control talks about controlling the sender based on the receiver capability. It does not talk about anything in the network. So congestion control talks about controlling the sender based on the network capability. So these are two different things as far as getting the reliability is concerned. Now, so if I want to, so I have already know. So as I say, so if I want to achieve flow control, I must know what is the receive window size. So receive window size is very, very important, crucial factor. So to achieve the flow control. Okay, so that is so. But in case of congestion control, similarly, we have to to achieve the congestion control, we have to deal with a window that is called as a congestion window. This is the receive window. This is called as the congestion window. We have to know what is the size of the congestion window so as to achieve the congestion control. Okay, now, so how we are achieving, we have already talked about. Send window is set with the capability of the receive window so as to achieve flow control. That means whatever is the capability of the receiver, I am setting the send window size as per the receiving window capability. So receiver window is set to the send window so flow control can be achieved. Similarly, to achieve the congestion control, what I have to do? The send window size has to be set as the congestion window, then only I could able to. So whatever is the minimum of these two, that should be set as the send window, then only you could able to achieve both flow control and congestion control. How TCP deals with the send window size has to be set with the minimum of whatever is minimum. Whether the receiver window is minimum, then that has to be set as the send window, and if the congestion window is minimum, that has to be set as the send window. Then only you could able to achieve the both, otherwise not. Now, next point, next crucial point. So we are talking about congestion. We are talking about congestion. But how to know there is a congestion occur? Can anybody just think of? अरे मैं पैकेट भेज रहा हूँ, कंजेशन नेटवर्क में हुआ है, कैसे मुझे पता चलेगा? भाई यू हैव पुट ना, जो दोनों के अंदर मिनिमम है, दैट इज माय सेंड विंडो. So under these circumstances, never it is going to happen. Okay, let me tell. Okay, very yes, anyone? Okay, let me tell. So let's say if I'm sending a packet. If I'm sending a packet, the packet is lost. Another packet I send, packet is lost. Another packet I send, packet is lost. What does it mean? Packet क्यों loss हो रहा है? What is the maximum chance? Maximum chance is the congestion. So there is a congestion in the network. So that's why my packet is losing. So that means the indication of congestion is packet loss. Try to understand this. If I'm sending packet in the network, if the packet is going fine, there is no congestion. If there is a packet loss, so there is a 90% chance packet loss happened due to congestion. Okay, that means the packet loss occurred due to congestion. Maximum chance is the congestion. I'm not saying 100% chance is congestion. So there is a maximum chance there is a congestion due to which packet loss is happening. That means packet loss is an indication of congestion. Now the next 2 points. How I can know there is a packet loss? Packet loss. So in normal scenario, so whether the timeout is a so I mean indication of heavy congestion, or 3 duplicate arc is a so indication of it. So that's why, so why 3 duplicate arc I receive? Because some packets has been received after so packet loss for certain duration. So that's why 3 duplicate arc is a lighter congestion. Right, understood? Because the packet is going after that, na? But here no packet is going. That's why there is a timeout occurring. Most probability. Okay, so that's why the probability of congestion is lighter if it is a 3 duplicate arc, and the probability of the congestion is heavier if it is a timeout. Try to understand. There is a heavy congestion if the timeout occur, and there is a lighter congestion if 3 duplicate arc I receive. As a consequence of it, I have to retransfer the packet. Okay, everybody understood now? Now the question is, we understood that what is the indication of congestion. Okay, and so now the next question is what to do. What is the idea? How to handle this congestion? What is the idea behind the same? The idea is, whenever there is no congestion, you go and increment. The congestion window. We talked about one congestion window, na? How the congestion window is going to change, so that depends on whether there is a congestion or there is no congestion. If there is no congestion, that means I send the packet, the other end is receiving the packet. There is no congestion. Whenever there is no congestion, you go and increment the congestion window. Okay, but so you are sending the packet and there is a congestion. That means there is some packet loss. If there is some packet loss, you decrement the congestion window so as to handle reliability, so as to achieve reliability, thereby handling the congestion. So whenever, let's say I am sending some packet, मान के चलिए हम कुछ packet भेज रहे, so now I see my packet is lost. Should I go and see? So should I go and send more packets into decrement the congestion window? If you decrement the congestion window, your send window will be decreased, thereby sending less number of packets as compared to the previous one, so thereby handling the congestion. So that's why if basic idea is, so that means when there is no congestion, you increment the congestion window. When there is a congestion, you decrement the congestion window so as to handle the congestion. So as far as TCP is concerned. But now the next question is, so I know, okay, I have to increment if there is no congestion, I have to decrement there is congestion. But now the question is, what should be the initial value of the congestion window? अरे congestion window का initially तो कुछ value देंगे, उसके बाद उसको बढ़ाएंगे या कमाएंगे. So whatever we are going to do, whether we are going to increase or decrease. So first of all, I have to give some initial value of the congestion window. Now the question is how to provide an initial value for the congestion window. How I am going to decide that? So for deciding this, so initial value of the congestion window, we have to understand there are some phases of congestion control. What are the various phases we have to follow as a part of congestion control? The first phase is called as slow start. And the second phase is called as congestion avoidance. There are two phases, so basically followed by earlier TCP. So to handle the congestion, so first one is called slow start, second one is called congestion avoidance. Okay, so by using this slow start and congestion avoidance, now we are going to decide how we are going to set the congestion window so as to deal all the scenario, the whole scenario to deal with the congestion. Now let's look into the next part of it. Okay, just 5 minutes I will take to go for it, then we'll go for the lab class. Okay, now so let's go for the slow start. Okay, as the name suggests, it is a slow start. We have to start slowly. So in order to start slowly, what the algorithm suggests that you set the congestion window. If the congestion window is 1 MSS, look into the scenario. If the congestion window is 1 MSS, so assuming that the same is going to set as send window. Send window is set on the based on congestion window. Send window is 1 MSS. That means I can only send one packet. Before receiving the ACK, how many packets I can go and send? Only one packet, na? So because one packet is 1 MSS, so now I receive an ACK. I send an data. Let's say data D0. I receive an ACK on behalf of it A1. Okay. So at this point of time, congestion window is 1. After receiving this ACK, what I'm going to do? Every time in the slow start, every time I'm receiving an ACK, I'm going to increment the congestion window by 1. Okay, I'm going to increment the congestion window by 1 after receiving an ACK. After receiving an ACK. So now tell me, when I go and receive this ACK, so what is the meaning it? If I'm going to receive an ACK, what is the meaning of it? Is there a congestion or there is no? My congestion window is becoming 2 MSS means what is the meaning of it? Now I can send 2 packets before receiving that. So now I go and send 2 packets. Now I go and send 2 packets. Let's say, so this is D1, this is D2. 2 more packets I can go and send before receiving that. Now I receive the ACK, let's say A2, let's say A3. I receive 2 ACKs. So every time I receive an ACK, my congestion window is incremented by 1. So when I receive the first ACK, my congestion window is becoming 3. Whenever I receive this ACK, my congestion window becomes 4. Okay, so once my congestion window becomes 4, what does it mean? I can send now 4 packets. That is the meaning of it. So I can go and send 4 packets before receiving that. I can go and send 4 packets before receiving that. Okay, so let's say D3, D4, D5. So now I go and receive 4 ACKs on behalf of it. So let's say it is A4, A5, A6, A7. So at this point of time, congestion window will be 5. At this point of time, congestion window will be 6. At this point of time, congestion window will be 7. At this point of time, congestion window will be 8. That means once congestion window becomes 8, that means now I can go and send 8 packets. See how the number of packets is going to send into the network is increasing. So by using this congestion window concept, slow start concept. So if I look into this, so see, so this is what is called as a RTT. Everybody understood, na? Sending a packet and receiving the ACK on behalf of it, that is called as an RTT. That means, so if I say at RTT 0, at RTT 0, what is the congestion window size? 1. At RTT 0, start with congestion window is 1. So RTT 0. So after receiving this, this is 1 RTT. So after RTT, 1 RTT, what is the congestion window size? 2. Okay. So this is another RTT. After, so 2 RTT. What is the congestion window size? 4. Look into this. So this is 1. This is 2 to the power 0. This is 2, 2 to the power 1. This is 4, 2 to the power 2. This is 8, 2 to the power 3. That means, see, so how the growth is happening? What type of growth it? So that means I'm saying it is a slow start. Don't be confused. Actually, this name slow start is misleading. Even if it is slow start, name is slow start, it starts slowly, but increase the window very rapidly. So that means at RTT3 window becomes 8. RTT4 window will be 16, double of it. That means there is exponential growth as far as this slow start. So what is going to concern? But ऐसे अगर करते जाएंगे, so obviously one time, so मान के चलिए, if we are going on the road, okay, there is a humps ahead. Why the humps is put? Because there is a chance of accident ahead. So that's why humps is the indication where you have to go slow. So that's why you cannot go in that speed, what speed you are going at this moment. Otherwise, there will be accident ahead. Okay, rather you go slowly once the hump is encountered, so ahead. So that's why that is the point. So that's why. So what is the hump here? So in order to get the hump, there is something called SS trace. SS trace. That is, SS stands for slow start threshold. Slow start threshold. There is a threshold value, and this threshold is nothing but the hump. In the road you are going, there is a hump. So convey you that, so there is a danger ahead, please go slow. Similarly here, there is a SS threshold value. Okay, when the congestion window size is either greater than or equals to SS threshold value, now it is a sufficient indication there is a danger ahead, there is a chance of congestion ahead. You please go slowly. Okay, so how to go slowly? So you have to change from slow start to the next page, that is called congestion avoidance. In order to go slowly, you have to change from the slow start phase to the congestion avoidance phase. because the slow state phase, even if the name is slow start, actually it is not slow. The growth is exponential. Not to stop this exponential growth, so we have to enter into the next phase, that is the congestion avoidance, where you have to go slowly. What the congestion avoidance is telling? The congestion avoidance is telling, so let's say my congestion window is 4 at this moment. If my congestion window is 4, congestion window plus 1. But what the congestion avoidance is saying, so whenever you receive, whenever you are receiving a congestion, arc, so the congestion will be incremented by congestion window plus 1 by congestion window. It is no more incremented by 1, rather it is going to be incremented by 1 by congestion window. So that's why, can you tell me, after receiving this arc, what will be the congestion window size? 4 plus 1 by 4. It is not 5, it is 4 plus 1 by 4. So then after receiving the second one, it is 4 plus 2 by 4. After receiving the third one, it is 4 plus 3 by 4. In case of a congestion avoidance, as we have to go slowly, so after 1 RTT, the congestion window becomes 5. This is how I could able to avoid the congestion as far as my TCP is concerned. So there are 2 phases. So one is called as a slow start. In the slow start phase, every time we receive an arc, the congestion window is incremented by 1. Okay, and thereby my growth is exponential. But if I talk about this congestion avoidance, in congestion avoidance, every time I receive an arc, so my congestion window is incremented by congestion window plus 1 by congestion window. So thereby, after 1 RTT, instead of becoming double the congestion window, it is becoming only incremented by 1. Okay, that's why. So we are going slowly to avoid the congestion. So ahead. This is how TCP handles the congestion. And in next classes, we are going to talk about congestion control algorithm. So in detail, how exactly these 2 phases and another phase is there also, combining all these phases. So how the congestion is happening in detail. If everybody, so how the congestion window is going to change from time to time. That's why we talked about 2 algorithms. Okay, one algorithm we talked about slow start. If you remember, what is a slow start algorithm we talked about? Another algorithm we talked about congestion avoidance. Congestion avoidance. Okay. As far as the slow start is concerned, so initially we are in slow start, and in the slow start we start with a congestion window of 1 MSS. Okay, to start with the slow start, the congestion window is set as 1 MSS, and every time we receive an arc, every time the arc is being received, when an arc is being received, the congestion window is incremented by 1, if you remember correctly. Okay, the congestion window is going to be incremented by 1 every time a valid arc is going to receive at the one end. Okay, and so as a consequence of it, due to this receive of, congestion window is incremented by 1 on receiving of every arc. So as a consequence of it, every RTT, if you remember, every RTT, the congestion window becomes double. Okay, so congestion window becomes double. Okay, so that's why, if you understood, so slow start, in the slow start, the growth is exponential. That is what we discussed in the last class. The growth is exponential. Why I'm saying the growth is exponential? If you remember correctly, at 0 RTT, the congestion window is set as 1 MSS. At 1 RTT, the congestion window comes to be 2 MSS. Congestion window comes to be 2 MSS. At 2 RTT, the congestion window comes to be 4 MSS. At 3 RTT, the congestion window happens to be 8 MSS. That means every RTT, the congestion window becomes double. So if I look into this trend, so 1 MSS, I can put it to the power 0. 2 MSS, I can go and put it to the power 1. So 4 MSS, I can go and put 2 to the power 2. And 8 MSS, I can go and put 8 to the power 3. So that's why the growth is exponential. So as far as this slow start, so algorithm is concerned, first of all, congestion window is set with 1 MSS. Then after receiving every arc, so the congestion window is incremented by 1. So as a result of it, every RTT, the congestion window becomes double. So as the congestion window in every RTT it becomes double, so the growth is exponential like this. 2 to the power 0, 2 to the power 1, 2 to the power 1, 2 to, sorry, 2 to the power 2, 2 to the power 3. Okay, this is what happens in case of slow start. Okay, so but if I go and increment, so my congestion window in this manner so fast, a time will come, so where the congestion is going to occur. So that's why in order to, so once a congestion is occurring, we have to go slow. So for that sake, so they have designed one threshold value that is called SS thres, that we have already talked about in the last class. That is slow start threshold value. Slow start, this is a very, very important concept. That's why I'm so repeating. So slow start threshold. So there is a slow start threshold value. Okay. So once my congestion window either greater than or equal to this SS thres value, the moment my congestion window is greater than the SS thres value or equals to SS thres value, so my algorithm changes from slow start to congestion avoidance. Try to start. So whenever we started with slow start. Okay, so then we go and increment our congestion window on an exponential basis. So a time will come when there is a congestion, or a time will come when my congestion window is going to exceed the SS thres value. The moment my congestion window exceeds the SS thres value, so now my algorithm changes from the slow start to congestion avoidance. Thereby, why I am changing from slow start to congestion avoidance? Because in slow start I am going very fast. So now already, there is a problem. So because this SS thres value, if you remember, I told, this SS thres value is just like a hump in the road. Okay, so in the road, whenever you go, you come across a lot of humps. So what is the purpose of putting humps in the road? So where there is a hump, so that means ahead there is a danger, there is a chance of accident ahead. So that's why they have put a hump, to minimize the accident. Similarly, so whenever we are talking about this SS thres value, this slow start threshold value is basically designed in such a way that there is a chance of packet collision ahead. So that's why once this slow start value is being encountered, once this slow start threshold value has been encountered, we should not go fast, rather we should go slowly. So in order to go slowly, I can't be in the slow start phase. I have to change into congestion avoidance phase. That means congestion avoidance phase, what it talks about. So if you receive an ACK, being in the congestion avoidance state, how the congestion window is going to increment? The congestion window is incremented like this. Congestion window plus 1 by congestion window. That means I'm not going to increment the congestion window by 1 every time when receiving an ACK. So as it happens in case of slow start. So in case of congestion avoidance, what I'm talking about, the congestion window will be incremented by 1 by congestion window. It is no more incremented by 1. So that's why as a result of it, every RTT, how the congestion window is incremented? The congestion window is incremented by 1. After every RTT, the congestion window is only incremented by 1. Okay. So previously, after every RTT, the congestion window becomes double. But now, in case of congestion avoidance, after every RTT, my congestion window only incremented by 1. So that's why, this kind of increase is a additive increase or linear increase. This is called as an additive increase. Okay, this is exponential, whereas this increase is additive or linear. That means, if I think of at, let's say 3 RTT, at 3 RTT, let's say the congestion window is 8 MSS. So now at 3 RTT, let's say when we entered into congestion avoidance, at 3 RTT, my congestion window is equals to 8 MSS. So at 4 RTT, my congestion window will become 9 MSS, not 16 MSS as in previous case of slow start. In slow start, if it could have been in slow start, so at 4 RTT, my congestion window will be 16 MSS. But as right now I am in congestion avoidance, after every RTT, now my congestion window is only incremented by 1. So that's why my congestion window right now is 9 MSS. Still, similarly, at 5 RTT, my congestion window is equals to 10 MSS. That means what I understood out of it, I'm not going very fast as in case of slow start, rather I'm going very slowly. So that is called as a additive. Okay. So the growth is additive or linear as far as congestion avoidance is concerned. Why I'm going slowly? Because I have already understood there is a chance of so accident or collision ahead. So very soon, so if I go slowly, so then so I could be rescued. Otherwise, it will be a problematic scenario for us. So that's why congestion avoidance is talking about this. Okay. Now this is what we have learned. Versions of TCP available. But as a part of your course, we are going to discuss about 2 versions of TCP. So the earlier version of the TCP is referred as a Tahoe version, and the recent version of the TCP is called as the Reno version. So there are two versions. There are 2 versions of TCP we are going to discuss as a part of this course. Okay. So, but actually, so there are a lot of versions of TCP available in reality. Okay. But mostly this version is being used by TCP nowadays. Okay. Reno version is being mostly followed by most of the TCP nowadays. So as a part of this, so we have to understood what is the earlier version. So what is the problem with the earlier version of Tahoe? So why so Reno has come into picture and how it can take care of this so problem that happened in case of a Tahoe version. Okay, let's start with the Tahoe version. Tahoe TCP. So how Tahoe TCP, Tahoe version of TCP, so implement this congestion control. So or implements this, so what slow start and congestion avoidance algorithm to control the congestion as far as the communication is concerned. Okay, so for that sake, let's try to understand this scenario. Based on this scenario, I will explain you. This is my TCP sender, let's say. This is the TCP receiver. Okay, so now first of all, so there are 2 states as I have already mentioned to you. So 2 algorithms, one is slow start, one is slow start, other one is congestion avoidance, other one is congestion avoidance, congestion avoidance. Okay, these are the 2 algorithms TCP Tahoe is going to. So when you start, what I have already told, when you start, you are in so slow start phase. So that's why. So let's look into this is called as a, so whatever diagram I am going to draw, so that is called as a so finite state machine. So that is a so bookish term, finite state machine. Also, you sometimes know this bookish term that is required sometimes in the examination, it will help. Otherwise, if you don't have heard about it, so आपको पता होगा concept, but you don't know this is called as a finite state machine. So that's why it is very, very important to read the book once to know the bookish terms. Okay. So now, so as far as slow start is concerned, when it starts, okay, now I talked about the sender. The sender starts. When the sender starts, now it is in slow start phase. Now the sender is in slow start phase. Okay, in the slow start phase, so what I have told, so what is my congestion window? We have to think of 2 parameters. So what is the congestion window? What is the value of initial value of the congestion window? So then what is the value of SS trace? Because we have already understood what is SS trace. These are the 2 important parameters which is going to help me to control the flow of packets as far as handling the congestion is concerned in the so network. So that's why so maybe so it depends on what is the MSS value, and mostly the congestion window is set as 1 MSS, and already we know what is the MSS. Now the next question is what should be the SS trace value? So remember this concept, this is actually implementation dependent. SS trace value, there is no specific value to be set for SS trace initially. Okay, so that is implementation dependent. Okay, but in the most implementation, if I think of, it is receiver window, whatever is the receiver window capability by 2. Whatever is the receiver window, because so before the communication starts between the sender and receiver, so during the connection establishment phase, both sender and receiver knows the capability of each other. That means so sender know what is the receiving capability of the receiver knows what is the capability of the sender. So that's why so that is already known so during the connection establishment phase. So once we know that, so we can set the SS trace value during the data communication, so by making half of it. But so again I am saying this is not fixed. This is depends on the implementation. This varies from implementation to implementation. Most of the implementation does that. That's why I have told it. Okay, that is the first concept you have to understood. So we start with the slow start, and my congestion window is 1. So now my congestion window is 1. Congestion window is equals to 1. So when the congestion window is 1 MSS, what does it mean? Now I can only maximum send 1 packet. So packet with 1 MSS only. Okay, so now you go and send packet with 1 MSS. Okay, yes, in success positive case, it is going to receive an ACK. Yes or no? It is going to receive an ACK. So being in the slow start, right now I'm in the slow start phase. Okay, slow start phase. No, I go and receive an ACK. This is the best case, best positive case can happen. So I go and receive an ACK. Receive an ACK. Being in the slow start, remember this concept. You are in the slow start. You go and send a packet and you receive an ACK on behalf of it. So you'll remain in the slow start. So that's why my diagram is like this. So I draw the diagram like this. That does mean that, so whenever I receive an ACK, so I remain in the slow start phase. Okay. So now I send one packet with 1 MSS. Now the receiver is going to receive it. After receiving the packet, so then it is going to send an ACK. In the most positive case, I'm going to receive this ACK. If I'm going to receive this ACK, what is going to happen? So I will remain in the slow start. I will remain in the slow start. So as a consequence of it, what are you going to do? My congestion window becomes 2 now. Okay, that means I increment the congestion window by 1 every time I receive an ACK being in the slow start phase. So in this case, so whenever there is a timeout scenario, let's try to understand what is going to happen. So if there is a timeout occurs, being in the slow state, remember this concept. Now you are in the slow state. Now you receive a timeout event. So when you receive a timeout event, again you are remain in the slow start. Okay. So if there is a timeout occur, you remain in the slow start. What is the so if that timeout is occur, what is the indication of that? What it indicates if a timeout occurs? So you are supposed to handle the congestion. So now you are sending some packets. Suddenly you find there is a timeout occur. What before decrementing the congestion window? What you do before decrementing the congestion window? First you adjust the SS thresh value. This is very, very important. So first you adjust the SS thresh value. So to what? Whatever is the congestion window, so divided by 2. So that means at whatever congestion window, so you encounter a congestion. So let's say, so now, so my congestion window is 2. Now I send 2 more packets. Now I go and send 2 more packets. Okay. So this packet is received. This ACK is received. Now I go and send 2 more packets. So as a result of it, I receive 2 ACKs. So at this point of time, my congestion window becomes 4. Okay. So now, so whenever my congestion window becomes 4, at this point of time, I send a packet that is lost. Let's say the packet is lost or the ACK is lost. So as a result of it, so at the time of congestion, what is my congestion window? So 4. So that's why. So now, so what will be my SS thresh value? SS thresh value will be current congestion window is 4 divided by 2. Now my new SS thresh value will become 2. That means, so the new SS thresh value depends on at what congestion has occurred. Okay, during the time the congestion has occurred, what is the congestion window? So that's why whatever is the congestion window during the congestion, so you divide it by 2, whatever value you got, so that becomes the new SS thresh value for you, and the congestion window will be restarted to 1. Okay, that means your congestion window again, so reset to 1 MSS, and your SS thresh value has been reset accordingly, and now so you again bring in the slow start. That means now you enter into the slow start. So this is very important point. If anybody did not understood, please ask. So now once again I'm repeating. Now let's say you are in slow start. Okay, now you are in slow start. You send a packet. You send a packet. Okay, but either you did not. So I mean either your packet is lost or you did not receive an ACK. So that is a timeout scenario is going to occur. If there is a timeout scenario occur, what I'm saying, you will remain in the slow start. You will not change the slow start phase. You will remain in the slow start. But what action you have to take being in the slow start? So first of all, you have to adjust your slow start threshold value, SS thresh value, to congestion window by 2. Okay. So congestion window is going to reset back to 1. Okay. So thereby, so again entering into slow start, and again you start from so 1 MSS like that means now you are again going to so start from the beginning. So that's why thereby going bit slowly. Okay, this is the reason why you are going back to it. Okay, this is one scenario. So can anybody think of another scenario? One scenario is you send a packet, ACK is, so you receive ACK successfully. Another scenario, you send a packet, ACK is lost or the packet is lost, so timeout occur. Can anybody think of another scenario? What may happen at the sender end? what may happen at the sender end? Does not segregate between the timeout and 3 duplicate act. Okay, so that means TCP Tahoe treats timeout and 3 duplicate act in the same manner. So that's why, so I'm saying even if it is a timeout or 3 duplicate act, the same action TCP Tahoe is going to take as far as handling the congestion is concerned. So what is going to do? So if either timeout occurs or 3 duplicate act occurs, so it is readjusting the SS thresh value so to half of the current congestion window, and then coming back, so the congestion window is reset to 1. That means, so in both the cases, so it doesn't matter whether it is a timeout or 3 duplicate act. In both the cases, so TCP Tahoe is doing the or taking the same action so to handle the congestion. Example, SS thresh is set to 3 MSS. After SS thresh is 3 MSS. Now you reach the congestion window of 4 MSS. What is going to happen? So now your congestion window is what? Exceeding the SS thresh value. What I have told. So whenever your congestion window exceeds SS thresh value, what you have to do? You have to go from the slow start to the congestion avoidance. So this is another important aspect you have to understand. So now you are in slow start. So at certain point of time, whenever you go on incrementing your congestion window, a time will come when your congestion window is exceeding the SS thresh value. So that condition you have to take care of. So whenever my congestion window is greater than or equals to SS thresh value. Okay, so when my congestion window is either greater than or equals to the SS threshold value, so that is being set at that point of time. So then it is going to, my algorithm, my congestion control is going to change from slow start algorithm to congestion avoidance algorithm. Why you have to go and change it? So because, so whenever it is crossing the SS thresh value, there is a danger ahead. So we should not go fast, rather we go slowly. So slow start phase is very, very fast, going very, very fast. So to the power of 2. So that's why it is exponential growth. So I should leave the exponential growth, rather I should enter into additive growth. So that is happening in congestion avoidance phase. So that's why I'm entering into congestion avoidance, whereas to go slowly so as to handle the congestion to certain extent. Okay, so that's why, so this is the first thing we have to understood when you are so change from slow start to congestion avoidance. Now we are entering into congestion avoidance. Okay, now let's say, so being in the congestion avoidance, so what can happen? Again, the same events may arise. So we are in congestion avoidance phase, same events may arise. We may receive an ACK. Yes or no? So we may receive an ACK. So being in the congestion avoidance page, we may receive an ACK. We may receive an ACK. So whenever we are going to receive an ACK, being in the congestion avoidance phase, we are going to remain in congestion avoidance. But we have to go slowly. How do I go slowly? So I have to increment the congestion window by 1 by congestion window. 1 by congestion. Getting my point? So previously we are incrementing by 1. So now I'm going to increment by 1 by congestion window. That is what we have already understood. But whenever you are receiving an ACK, bring in the congestion avoidance. So algorithm. So my congestion window is going to be incremented by 1. What other event can occur? Can anybody tell me? So that timeout and 3 duplicate ACK. Yes. So being in the congestion avoidance, even if we go very slowly, अरे मान के चलिए अब आपका 4 था, so after one RTT it becomes 5, after another RTT it becomes 6, another RTT becomes 7. Even if you go slowly, again there is a chance, even in the road, so you are going very slowly, so पीछे से कोई आके आपको एक्सीडेंट कराएगा. So you can't give the guarantee. Even if you go slowly, मैं slow जा रहा हूँ, मेरा एक्सीडेंट कभी नहीं होगा. You cannot give this guarantee. So that's why even if you go slowly, so in a congestion avoidance phase, so there will be a chance where there will be a congestion. Okay, so that means a congestion means there will be a timeout or there is a 3 duplicate ACK. So that means, so at that point of time, always remember this concept. So whenever there is a congestion occurred, so because of the timeout or 3 duplicate ACK, you have to come back to the slow start phase. Okay, so that's why right now we are in congestion avoidance phase. So we have to come back to the slow start phase. Okay, so when the timeout occur, or 3 duplicate ACK is being received. So what is the indication of a congestion? That means if a congestion has occurred, so being in the congestion avoidance state, so I should come back to the slow start. And when I come back to the slow start, what I have to do? So again the same adjustment I have to do. SS thresh SS thresh has to be set with the current congestion window divided by 2, and so my congestion window again fall back to 1. Okay, thereby coming back to the what slow start phase. This is how TCP Tahoe version could able to handle the congestion by using this two algorithm and changing one algorithm from other to one to other depending on the circumstances. Is it understood, or anybody who was using TCP Tahoe was using two algorithms? So one is slow start, other one is congestion avoidance. These are the two algorithms used by TCP Tahoe to handle the congestion. But now one more addition is going to done by this TCP Reno version. So that is called as a fast recovery algorithm. Another algorithm is being added on top of it. That is called as fast recovery. So it introduces this algorithm to handle the congestion for 3 duplicate acts separately. So now let's look into how exactly it is going to do it. So now start with the same thing that we start with the TCP Tahoe version. So being in the slow start, I receive an act. When I go and receive an act being in slow start, so what is happening? So now I remain in slow start and my congestion window is incremented by 1. That we have already known. So the same thing is going to happen also here. No change. Okay. So now, what other event can occur? Timeout event can occur. A timeout event can occur. Exactly the same way it is going to handle the timeout, the way it is handling in case of TCP Tahoe version. So that is timeout occur. So when timeout occur, so how I am adjusting the SS threshold? Okay, this is what we have done in TCP Tahoe. Exactly the same thing we are going to do in the TCP Reno version. But so there is a change here. So in case of TCP Tahoe version, so it is using for the timeout, also for the 3 duplicate act. But it is not going to happen for 3 duplicate act in case of TCP Reno version. Now, so forget about 3 duplicate act for the time being. What other event can is? So right now we are in slow start, and whatever is my congestion window, that is either greater than or equals to SS thresh value. If it is, I should enter into congestion avoidance to handle the congestion. Okay. So now, so forget about, मैं अभी 3 duplicate act के बारे में नहीं बोल रहा हूँ. अभी दूसरा पार्ट कर लीजिए, बाद में हम बोलेंगे 3 duplicate act. Now we are into congestion avoidance. Yes, very nice. We go and receive an act. If I go and receive an act. So how the congestion window is going to increment? Congestion window is equal to, always this is the thumb rule. Remember this thumb rule. In case of timeout, so always you have to come back to slow start in whichever state we are, doesn't matter. Okay, that is the thumb rule. We should come out of the any other states and come back to the slow start state. So that's why if there is a timeout occur, we come back to the slow start, and by resetting the SS thresh value to congestion window upon 2, and congestion window again fall back to 1. This is the thumb rule. Timeout, come back to slow start and readjust the SS thresh and congestion window like this. Wherever you are, doesn't matter. So now, so remain is the what? So 3 duplicate act. Okay, now in these circumstances, what happens? So now let's say I am right now in slow start phase. I receive 3 duplicate act. Now I am in slow start phase and I receive 3 duplicate act. 3 duplicate act being in the slow start. First of all, remember this is another thumb rule. So whenever 3 duplicate act is encountered in whichever state you are, so you have to come back to fast recovery. Okay, so in order to get recovered from the 3 duplicate act problem, so you have to come to fast recovery phase. So that's why, so if you are in slow start, you receive 3 duplicate act, you have to come back to fast recovery. What you have to do, that is important to understand. Now let's say how adjustment is going to happen here. So SS thresh, first of all, adjustment is going to happen on SS thresh. SS thresh also follows the same rule. Whatever is the current congestion window, so upon 2, so that gives my new threshold value. Okay, So whenever any problematic scenario comes, another thumb rule. So SS thresh has always to be readjusted back to congestion, current congestion window divided by 2. Okay. So, but what about the congestion window? That is very, very important to understood in case of 3 duplicate arc. So previously in case of timeout, we are falling back to 1. As I'm saying, falling back to 1 is not a good idea. So because my performance is going to hamper, and 3 duplicate arc says that I have already recovered from the congestion. So can anybody think of logically? Just a minute. Okay, so SS thresh. But now, so what is the, so let me give the scenario to make you understood what exactly how I am going to do it. So let's say I send a packet with sequence number D0 that is lost. Then I go and send 3 more packets. D1, D2, D3. Okay. Now I receive arc on behalf of them. So what I'm saying, whenever I'm receiving 3 duplicate arc, I'm saying I go back to, so SS thresh. SS thresh. My safest point is go back to SS thresh. Okay. But so if I have मान के चलिए, so my safest point is SS thresh, I go back to that. So whenever I send a packet, I receive an arc. What is the meaning of it? There is no congestion or congestion. So I receive the second arc. That means, so now I again send 1 more data and I got it. So that's why my next, so congestion window should be SS thresh plus 2. Similarly, I receive the third arc and I got it. I sent the third packet and I got it. So that's why, so my new congestion window should be SS thresh plus 3. So that's why, so my congestion window is set as SS thresh plus 3 whenever I receive 3 duplicate arc. First try to understand this. So when there is a 3 duplicate arc, so that does mean that, so there is no more congestion. If there is no more congestion, so I should not fall back to 1. Rather, my safest point, I should fall back to my safest point. That is SS thresh. But why I'm making plus 3? Because he's saying that 3 duplicate arc indicating me that, so 3 packets has been sent and so the receiver has received it. So better, so when so receiver has received and send an arc on behalf of it, we are always incrementing the window by 1. So that's why as I receive 3 duplicate arc, so I go and increment my safest point by 3 more. So that's why my new congestion window becomes SS thresh plus 3. So everybody got this point, or anybody has another scenario? Let's say I don't have any more packet. So what is going to happen after? So 3 duplicate arc I receive. So I have to retransmit the D0 packet. So as a consequence of it, I'm going to again receive an arc. Can anybody tell me what will be the arc number I'm going to receive in the arc of this? This arc is going to
D3
going to come. In one case, I'm saying a duplicate arc is going to receive. Duplicate arc is going to receive. If a duplicate arc is going to receive, can anybody think of what should I do? What should I do? If I'm receiving once more a duplicate arc, so I should increment my congestion window by 1. Are yes or no? Okay. So, but so now, if I do receive a new arc, can anybody think of? If I receive a new arc, what should I do? What should I do? See, so if I one more rule I am going to tell, so then you'll only able to answer. So whenever I receive a new arc, what does it mean? I completely recovered from the situation. Yes or no? If I receive a new arc, so that means I completely recovered from the bad situation. Okay, unless until I receive a new arc, I have not completely yet recovered from the bad situation. So when you are completely removed from a bad situation, so first of all you have to understood, you have to leave the fast recovery. Fast recovery को आपको छोड़ना होगा. जब, so whenever you are going to so completely recover from the bad situation, so congestion, so at that point of time, so you have to make sure that you have to leave the fast recovery. Now if you are leaving the fast recovery, so what is the choice? Either you have to go back to slow more than that. Okay, so that's why I am going to reset the back, so the congestion window with the SS thresh value, and I am entering into congestion avoidance. So that's why, so being in the fast recovery, if I go and receive a new arc, so I should adjust my congestion window with the SS thresh value, and I should enter into congestion avoidance where I can go slowly because there is a chance of congestion ahead because my congestion window is currently SS thresh value. Okay, so now what other scenario, what other event may occur? Can anybody think of? There is one more event can occur. Again, it is lost. हो सकता है ना, You cannot give the guarantee. So D0 उसके बाद भेजे, so फिर D0 loss हो गया, हो सकता है. So in that case, if I do not have any more packet to send, so what is ultimately going to happen? So timeout is going to occur. Okay. So after receiving 3 duplicate ARC, if I retransmit the packet and the packet is lost and I have no more packet to send, ultimately as a result, so timeout is going to occur. If you are encountering a timeout, you have to go back to slow start. So that's why being in the fast recovery. So if there is a timeout occur, you have to go back to slow start. So by adjusting the same way, SS trace is equal to congestion window to, yes, and current congestion window, congestion avoidance, you are going to encounter 3 duplicate. And the thumb rule is that, so if you are encountering so 3 duplicate ARC, irrespective of which algorithm you are, you have to come back to which algorithm? Fast recovery. 3 duplicate ARC. So being in the congestion avoidance, I have to go back to here. Okay. So then in that case, again, if it is a 3 duplicate ARC, the rule is same. So SS trace is equal to current congestion window divided by 2, and then congestion window is equal to SS trace plus 3. Okay. So by doing this, you are going to come back to fast recovery and show the same, all the events you have to have. I mean, so in the fast recovery, again, depending on the events you have to handle, and you have to come back to either slow start and congestion avoidance from time to time. This is how completely TCP Reno version takes care of the congestion control and handle the 3 duplicate ARC in a separate way, to get better performance on top of the data transmission. So by handling the congestion. So this is all about how TCP Reno does this diagram. In the x-axis, it is saying the RTT. In the y-axis, it is taking into consideration the congestion window. Okay. So with respect to that, when you start with the Reno TCP, we start with the slow start phase. At the 0 RTT, what is the congestion window? At the 0 RTT, 1 MSS. So it is 1 MSS, set as 1 MSS. Okay. Then right now we are in slow start. So after 1 RTT, what will be the congestion window? 4 MSS. So after 3 RTT, again it will be double, it becomes 8 MSS. Now at 3 RTT, so my congestion window becomes 8 MSS. But suddenly a timeout occurs at this point of time. At this point of time, let's say there is a timeout. So if there is a timeout, what is the rule? Can you tell me please now? Participate please everybody. The congestion window falls back to 1. So that's why, directly from here, my graph comes here. So saying that my congestion window is 1 at 3. Okay. And my SS thresh value at that point of time is set back to 4. Okay. And initially, this is the threshold value set. That doesn't matter much as far as this example is here, but this is the initial value. Try to understand. Okay, now, so tell me one more point. So in which we are in slow start, so again it becomes double. Okay, so 1 to 2. So in the 5th RTT, again it becomes double. So 2 to 4. Can anybody think is 4? And my congestion window is also 4. Both are same. So that condition, in that condition, I should go from changing from so my slow start phase to the congestion avoidance. So that's why congestion avoidance phase starts from here. Okay. So this point congestion avoidance starts. So once congestion avoidance starts, at this point, what happens? So my congestion window is 4. So after one more RTT, it will no more be double. It will be 5 just by 1. In next 7 RTT, it will be again 1 more. So 6. In 8 RTT, it will be again 1 more. 7. So in 9 RTT, it will be 1 more. 8. In 10 RTT, it will be 1 more. So in 9. So in 11 RTT, it will be 10. And in 12 RTT, it will be 1 more. So that is 11. And at 13 RTT, it becomes 12. So when it becomes 12, at 13 RTT, suddenly 3 duplicate ARCs receives. Can anybody tell me what changes? Back from 12 to 9. But if it could have been TCP Tahoe, so back is from 12 to 9. This is where there is an improvement of performance. Okay, so it is not falling back to 1 again to start from back from 1, rather it is falling to 9 and start from there onwards. So there is an improvement of the performance. Now in 13 RTT, being in 13 RTT, I receive 1 more ARC. So what is going to happen? So that means my so this 10 to 11, 1 more increment. So at this point of time, at 15 RTT, now I'm going to receive a new ARC. Now I'm receiving a new ARC. So when I'm receiving a new work, so being in the fast recovery phase, what is going to happen? Can anybody explain? Back from here to 6 while entering into congestion avoidance, there is a fallback from here to 6. So now we are in 6. Okay, now after that, I'm in congestion avoidance. In every RTT there is one more increment, so 6 to 7, then in next RTT 7 to 8, so then next RTT 8 to 9, and next RTT 9 to 10, in next RTT it becomes 11. Like this it goes on depending on various events time to time, so that occur during the transmission of the packet to change from slow start to congestion avoidance to fast recovery to come back to congestion avoidance, or fast recovery to come back to slow start. So this is how from time to time the states are going to, all algorithms are going to change to handle the congestion and also maintain the efficiency as far as the data transmission is concerned. So therefore Renault TCP is a latest version of TCP on top of the earlier version of the TCP Tahoe. And mostly, if you look into the real implementation, most of the TCP implementation nowadays is using this Renault version. Okay.